logarithmic function. So these first two sections dealt with exponential form. Okay, the logarithmic function, the general form looks like the following. So it's log a of x. That's kind of the wording of it. Okay, so y equals log a of x. Okay, so this is the log form. And now, this is only true if the following relationship works. Okay? If you take this log base a of x, okay? So you'll hear me refer to this as a base, and one of the main reasons is it allows you to be able to transfer or convert back and forth between the log form and the exponential form. And so just like all the other operations that you guys have dealt with, the exponential form has an inverse. And so addition, what is the inverse of addition? Subtraction, right? The additive inverse is the opposite. What's the inverse of multiplication? Division, right? The multiplicative inverse is a reciprocal, which is also division. And for exponential forms, the logarithm is the inverse. Okay? And so if you look at this log, this form of a log, you can convert it directly back into an exponential form where this base is the base of an exponent. You'll take it to the power of whatever it's set equal to, and that's going to equal whatever is inside your log. And so this is the exponential form. For whose inverse the log form looks like this. Okay, so there's a couple things that you are going to need to be able to do. The first is to convert from a log to an exponent. Okay, so if I gave you something that looked like this, log 5 of 125 is equal to 3. So if I give you this full statement, and I ask you to convert this into its exponential form, the way that you're going to do that is you use this kind of cyclical pattern here. You take your base, 5, to the power of whatever number is on the other side of the equation, 3, and you're going to set that equal to whatever is inside your log, 125. Okay, so this is the exponential form. Right? This is the log form. And they represent the same thing.
So it's kind of like where would finding square roots and the roots be?
So, well, if you know the whole thing, and we'll talk about when you're solving equations, I think maybe is where you're headed. If this had been a variable here, and you had to solve it, you would use, I think, what you're talking about. Let me kind of go through this, and then if it addresses it, it should answer the question, and if not, I'll reattempt to answer it. Okay. So let's take one more example of this. Okay, let's say you take log base 100 of 10 is equal to 1/2, and I ask you to find the exponential form of this. I want you just to see if you can use this pattern and figure what that would be. The base of your log is the base of your exponent, so 100 to the power of whatever's on its own side of the equation, 1/2, and that's going to equal the number inside your log, 10. Okay. All right, now, in addition to this, you'll also need to be able to convert from the exponential form into the log form. Okay, if this is the case, again, it's the same kind of idea if we start with an exponent. And we want to write this in log form. Okay? Again, if you listen to the wording that I use, it helps identify the form that you write it. Okay, so I'm going to start with my base. So I'm going to take the log base. And again, I use that term base. It identifies it's the base of our power, or of our exponent. And then I'm just going to use this relationship. I'm going to use this figure or this relationship anytime I draw these. So if I take this base to the power of what is equal to what? What goes over here? 2. And what goes inside the log? 9. And so it fits that same pattern. 3 to the power of 2 is equal to 9. So I'm using the pattern of the logs even when I convert in either direction. Doesn't matter which direction I'm converting. That's kind of the interpretation I use. Okay, so what if I take 8 to the 1/3 is equal to 2? And see if you can write the log form of that, please. So you can take the log base 8. On the other side of the equation, we can write the power 1/3, because again, 8 to the power of 1/3 is going to equal what goes inside the log? 2. And so that's how you can convert back and forth between these. Right?